Hey everyone, in this lecture we're going to be addressing a very important conceptual question. How good is your experiment, and what makes your experiment good? Let's get started. So I want to clear things up about my terminology that I'm going to be using from here on out. For now, experiments are going to include observational studies. So I'm not going to be saying observational studies and experiments from now on. I'm just going to be saying experiments. But really what I'm referring to are both observational studies and experiments. So I want you to pause this video and try to address this question. When should your hypothesis be accepted or rejected by the scientific community? Think about this. All right, so I want to address this question by working through an example together. Suppose you sample 1,000 people and you find that the average age is 25.07. Now let's assume that you obtained those 1,000 people through some very random process from the US population. Can you really make the claim that the average age in the US is 25.07? Pause the video and try to give me an answer to that question and explain why. Now I believe that it could be the case that those 1,000 people, all of them happen to be college students. And that is possible. If you randomly sample the US, it is completely plausible that all of your students are freshmen in college. Now it's unlikely, but it is absolutely possible. Even though you're picking randomly, it could be that your random sample happens to look slightly biased. That actually happens, and you should have the expectation that that happens. So can you really make the claim that the average age is 25.07? I would argue no, but I would argue that there's something special about that number, and we're going to discuss that later on. All right, so 25.07 is not the average age of the US. I think we can agree on that. But what made our experiment wrong? Is it that the 1,000 people lied to us? Do we need to sample more people? What made our number, our calculation, wrong? Suppose I do an experiment. Same experiment, I sample 1,000 people. Am I going to get an average of 25.07? All right, I know this seems problematic, but it's actually not. There is a fix to this, and we're going to be talking about this fix. Think of it this way. If I sample 1,000 people, am I going to get an average age of 25.07? Probably not. However, I would argue that my answer is probably going to be close to 25.07. Now, what does close mean? We'll talk about that later on too. All right, so now I want you to imagine 500 scientists conducting the same exact study. Now, they're different samples, but they're all going to randomly sample 1,000 people and calculate the average age of their sample. Are all of these scientists going to get the same answer, 25.07? Of course not. Now, their answers should be relatively close, and there might be some outliers, but it's important to understand that these scientists' answers, their averages that they calculate, those statistics are going to be spread out a little bit. There are going to be some differences amongst our results. Now, it's really important to understand that your experiment is among many possible experiments using different samples. So when you do an experiment, you should have the expectation that whatever statistic you calculate, it's going to be a little bit off. I really want to emphasize this point. The average age of the US is not 25.07, and no one should claim that it is, even though your experiment said that the average of your sample is 25.07. Basically, the idea is if you ever make an inference about the population, you should never claim that you know what the population average is, because you really only know the average of your sample. And not every inference is exactly correct, but they are still educated guesses. So here's the main idea. When you conduct a really good study like that, you should say that the average age is around 25.07. You should never make a claim that the average age is 25.07 in the US. Now you can claim that the average age of your sample was 25.07. That's perfectly fine because it's absolutely true. You did the math, and assuming you did your math correctly, that's the average age of your sample. not of the population. So you should never make a claim about the population. You should only guesstimate or say that the population averages around 25.07. Anyways, in the upcoming lectures, we're going to be talking about what the word around means, because it's a very important word to understand, especially when we conduct experiments. See you guys in the upcoming lectures. You just watched a video from More Learning. We provide free math videos and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. And put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.